All right, the AI scientist towards fully automated, open-ended scientific discovery by Sakana. One of the grand challenges of AGI is developing agents capable of conducting scientific research and discovering new knowledge. While fraud-2 models have already been used as aids to human scientists for brainstorming ideas, write code, or prediction tasks, they still conduct only a small part of the process. This paper presents the first comprehensive framework for fully automatic scientific discovery, enabling frontier LLMs to perform research independently and communicate their findings. We introduce the AI scientist, which generates the novel research ideas, writes code, executes experiments, visualizes results, describes its finding by writing a full scientific paper, and then runs a simulated review process for evaluation. In principle, this process can be repeated to iteratively develop ideas in an open-ended fashion and add them to a growing archive of knowledge, acting like the human scientific community. We demonstrate the versatility of this approach by applying it to three distinct subfields of machine learning: diffusion, transformers, and learning dynamics. Each idea is implemented and turned into a full paper for $15. To evaluate the papers, they design and validate an automated reviewer, which we show achieves near human performance in evaluating paper scores. Wow. The AI scientists can produce papers that exceed the acceptance threshold at a top machine learning conference, as judged by our automated reviewer. This approach signifies the beginning of a new era in scientific discovery and machine learning, bringing the transformative benefits of AI agents to the entire research process of AI itself, and taking us closer to a world where endless, affordable creativity and innovation could be unleashed on the world's most challenging problems. The code is open source. The modern scientific method is arguably one of the greatest achievements of the Enlightenment. A human researcher collects background knowledge, drafts a set of public hypotheses to test, constructs an evaluation procedure, and collects evidence for different hypotheses, and finally assesses and communicates their findings. Afterward, the resulting manuscript undergoes peer review and subsequent iterations of refinement. This procedure has led to countless breakthroughs in science and technology, improving human quality of life. However, this iterative process is inherently limited by humans' researchers' ingenuity, background knowledge, and finite time. In the field of AI, researchers have envisioned the possibility of automating AI research using AI itself. Models like foundation models from Anthropic, DeepMind, Llama, and OpenAI have tried this, but they have only shown to accelerate individual parts of the pipeline. Traditional approaches to automating research projects have so far relied on carefully constraining the search space of potential discoveries, which severely limits the scope of exploration and requires substantial human expertise in design. For example, significant advancements in materials discovery and synthetic biology have been achieved by restricting exploration to a well-characterized domain with predefined parameters, which allow for targeted progress but limits broader open-ended discovery and addresses only a subset of the scientific process. In this paper, they introduce AI scientist, more like AI research swarm would be a more fitting name. It's not just one scientist, is it? The first fully automated and scalable pipeline for end-to-end paper generation, enabled by recent advances in foundation models. Given a broad research direction and a simple initial code base, the AI scientist seamlessly performs ideation, a literature search, experiment planning, experiment iterations, manuscript writing, and peer review. It can run in an open-ended loop. building on previous scientific discoveries to improve the next generation. This allows us to speed up the slow nature of scientific iteration at a low financial cost of $15 a paper. This could also be applied for biology or physics. By leveraging modern LLM frameworks like chain of thought and self-reflection, the AI scientist is able to generate its own scientific ideas and hypotheses, as well as planning for testing them with experiments. Next, the AI scientist implements plan-directed code-level changes to the experiment template using the state-of-the-art coding assistant Aider, who executes experiments to collect a set of results. The AI scientist then performs a fully automated paper reviewing process using guidelines from an ML conference. Adds the completed the scientist adds the completed ideas and reviewer feedback to its archive of findings, and then the process repeats. The generated paper and experimental artifacts the scientist produced allow us to easily interpret and judge its findings post hoc, allowing human scientists to benefit from what is learned. This is really important because having AIs build better AIs than the predecessors, there has to be some evolutionary process here. There has to be there has to be there has to be a replication / evolutionary process for AI to keep progressing. You have to have AIs working on AIs because AIs are better at building AIs than humans. So, our contributions are summarized as follows. We introduced the first end-to-end framework for fully automated scientific discovery and machine learning research enabled by frontier LLMs. This fully automated process includes idea generation, experiment design, execution, and visualization. To assess the quality of the generated papers, we introduced a foundation model-based reviewing process. This process achieves near human-level performance across multiple eval metrics, 65 versus 66. And this is the loop. So first thing we got here is we got an idea. So that's plan. What is the agent going to work on? And then there's a novelty check. What is that? Semantic scholar. Based on how new the idea is, it should be very new. If it's not new, it's probably not worth it. Idea scoring, archiving. Are these all different agents or one agent? I'm very curious. So then after idea scoring, then we have a template. Then we create the code, and then we have another agent create the scripts, the experiment scripts, and then we do that in a loop basically. Then once the results are finished, we pass the results, and we have an agent that builds data plots, and then there's the paper write-up agent. Manuscript template, text VI LLM. So this is basically like a sequential pipeline. You have one agent, one agent, one agent, one agent, one agent. Nicholas, what do you think? Yeah, and assesses the novelty of a set of ideas. Determines how to test the hypotheses, including writing the necessary code. Afterward, the experiments are automatically executed to collect a set of results consisting of both numerical and visual summaries, plots or tables. The results are motivated, explained, and summarized in a LaTeX report. Um, so they probably have generated hundreds of papers. We have worked on something very similar, but not papers, mostly just code, with some theory. Uh, we have generated thousands of them, but basically, like, here is a Hugging Face data set of it. Basically, we try to create entirely new neural net designs. So we give, like, the theory combines the principles of hypergraph neural networks with tensor product spaces for multimodal learning. So it's a hypergraph, and then you have code, you know. So, and most of the code, like, the quality of code is growing very quickly. I mean, like, very, very fast. So, yeah. So, let's see. LLM agent frameworks. So, LLMs often involve embedding the model into an agent framework, including the following possibilities. The structuring of language queries, few-shot prompting, encouraging reasoning traces, chain of thought, or asking the model to iteratively refine its outputs. Self-reflection. These leverage the language model's ability to learn in context and can greatly improve its performance and robustness. So Aider, their coding assistant, uses state-of-the-art open-source assistant. Aider is an agent framework that is designed to implement requested features, bugs, or refactor code in existing code bases. While Aider can in principle use any underlying LLM with frontier models, it achieves a remarkable success of 18.9% on the software engineering benchmark, a collection of real-world GitHub issues. In conjunction with new innovations added in this process, this level of reliability enables us for the first time to fully automate the ML research process. All right, so idea generation. So they have a template.
Does it repair a repository also for, like...
Yeah, it does. Well, Aider does, yeah.
Oh, nice.
You should check it out. All right, so idea generation. An agent brainstorms a diverse set of research direction. We take inspiration from evolutionary computation and iteratively grow on an archive of ideas using LLMs as a mutation operator. Each idea contains a description, experiment, execute plan, and numerical interesting scores, self-assessed numerical scores of interestingness, novelty, and feasibility. If you wanted to do this from scratch, I'm gonna kind of like implement this kind of from scratch, so I could demonstrate how to do this from scratch. So let's open up Swarmies. I'm gonna go to agents, structured outputs, function calling. All right, so we're gonna idea generator agent. We're gonna work on this. Okay. So what does it do? Uh, so okay. First, we need to make a schema. I bet we could probably make a better version of this paper than these people if we like very carefully, and craftily craft this out. So okay.
I feel like a swarm of like research agents, like at a minimum, some sort of like mixture of experts or mixture of agents would be like a pretty easy add-on.
Yeah.
I just like cluster each task with multiple agents instead of just one.
Experiment plan. So yeah, I'm gonna show you how like we could like replicate this paper with some simplicity. Experiments, then we have some scores. So interestingness is gonna be an int. We're gonna do from 0 to 1 a rating of how interesting the paper idea is on a scale from 0.1 to 1.0 being the most innovative. Novelty. And feasibility. Yeah. So after idea generation, they filter ideas by connecting the LLM with the Semantic Scholar API and web access as a tool. So it basically searches existing literature. Isn't that cool? So
That's for the novelty check.
Yeah.
It should be able to browse archive. Also.
Yeah.
Like that should be baseline.
So this right here, I mean, that's pretty much like we could generate multiple papers already with this schema. We're going to pass this in. So it's going to generate multiple of these paper ideas. But the thing is, we need a good prompt, which is the hard part, I guess.
What's their baseline? Or do you like to attempt pure inspiration?
What was that?
I was saying, do you like to attempt pure inspiration, or do you want to just reference theirs in the paper?
I want to create our own prompts. What were you saying? I was trying to implement this fucking schema.
No. Nothing. No, nothing really.
Okay. Call the function. Okay. All right. See. Generates paper ideas for multi-agents learning involving transformers and LSTMs. Fuck. Let's see what we get. Oh, no examples. All right, let's see what it got. Wait, I can make this look better. So it came out with some paper ideas. Transformer LLM LSTM hybrid model. This paper proposed a new hybrid model that combines the strengths of transformers and LSTMs. The model leverages the transformer's ability to capture well, what the hell is this then? Let's see. Attention augmented LSTMs. What the fuck? An attention mechanism into LSTMs to create a more robust model for oh, that's already a okay. Let's generate paper ideas for multi-agent learning involving many.
Try collective intelligence.
Yeah, let's see. I was trying to format it so it could look nice. Yeah. Okay. Yeah, so basically it does the same exact thing that they have in the paper, but in a function calling way. You have the paper ideas, right? Description, experiment, interestingness, novelty, feasibility. Hierarchical transformer ensembles for decentralized decision making. Introduces a hierarchical structure of transformer models that operate at different levels of decision making in a decentralized multi-agent system. Low-level transformers handle local decisions, while high-level transformers integrate information for global strategy. That sounds fun. Yeah. Basically, this form of research is very important. I don't know. They're doing research. They're generating research papers with just one LLM. I think this is the future. Multi-agent, like involving multiple transformers, involving multiple multiple transformers, multiple LSTMs, multiple Mambas, multiple attentions. That's I think that's the future.
I like the idea of like Monte Carlo exploring different possible combinations. I mean, there's, and just model sizing alone and like training methods. There's so many different ways to like tweak the recipe. you need pretty robust experiment tracking. But I feel like what's the actual utility of this paper?
To generate infinite papers without having to actually do papers.
So, but what's the purpose if nobody ever reads like most of the papers? You would want some sort of like reporting mechanism to demonstrate the either first off you have your novelty scores, you've got your interesting scores, but then like do you have like the trace of like what it looked at, like do you have evaluation? Do we run evaluations on like characterizing what interesting and those other things are across all of the agents in different runs?
Let's see.
Maybe some more advanced sufficiency criteria.
Yeah. So they have the prompts here. I'm looking at the prompt they use. They just built this so ineffectively. They're still using like they're still doing this. They're not using function calling. It's kind of dumb. All right, let's run it. Let's run it again and just
codifying the scientific method is pretty incredible, though. I mean,
yeah, 100.
I'd like to build all the pipelines for the entire data science like life cycle, and it would be, I think, possible to credit like a given agent or agent combination with like different training opportunities. I think it'd be really interesting to see how different the papers generated are if you try to make them like more legible for like a broader audience, or if you added like brochures, LinkedIn posts that like complement the research, the code, and like trace data sets.
So many there, but the thing is though, they'll like there's infinite paper ideas that need to be tested in some way. Science is really just the exploration of what works and what doesn't work.
For sure. How do you know that even the effort that you do put in though was worth it? Like making sure that
if it works
you have to decide what
consistently.
the quality bar is at some point.
Yeah, I mean, if it works consistently, then, like if the process is, like if something works every time you try it, that's obviously very valuable. Like that's science. Repeated experiments, the ability to do multiple experiments.
Reproducibility.
Yeah, like all at the same time. So.
Well, it's reproducible if you just write down what you use.
Yeah. Hey, Zach, are you here? We're reading a super cool paper, where like AI creates a swarm of agents build research papers.
Yeah, it's very interesting. Yeah, I think it just comes down to benchmarking in terms of determining quality. But yeah, it's very, very cool they're able to kind of automate the scientific method to some degree.
I feel like many applications live and die by their evaluations. or at least in like for these kinds of papers. It'd be interesting to kind of discuss what possible evaluations would look like that would be like credible within the community.
Yeah, I think it'd be cool to have like a lab tech tree of, latest in the different fields of technology.
Well, I do actually have something like that. Like that I follow. If you could implement the entire process as a dashboard if you really wanted to, but the this one. Top papers.
Yeah.
Have you guys seen this Emergent Mind?
Yeah, so I've seen something similar. Like Papers with Code has a section similar to this, just top papers in all the subjects, but they're also filtered to only include ones with code implementations.
Good. There's also this other platform that AI2 does.
Could you send these links?
Yeah.
But yeah, just something to like. I almost want to build something, but just something to aggregate all of them and suss out. Like it would also have to include better benchmarking. I don't know if you can really go off of what the paper says.
Yeah, a benchmark, I think,
it has to assess papers.
You would have to use an example. Like, let's say that we use Attention is All You Need, the Boltzmann Machines paper from what's his face, and then you use like some of these like seminal papers that are supposed to be like some of the most elegantly like done, like ended up like research. I don't know, like equations even turned out nicely kind of thing. And you use that as some sort of gold standard, bronze standard, and silver standard, and you like provide the examples to the LLM in some sort of compressed format.
Yeah.
That's my first intuition, because you just say, okay, what's a good paper? And feed it a couple examples of those, and you have it self-reflect on, you could even have it have a couple of agents argue over semantics. In fact, I think a great evaluation that all of us should get behind is having the three old guys from the Muppets argue about if the paper's better or not. Now I think that's research that needs to happen in the world.
Make some Muppet agents, set them to continuously talk to each other on a topic. There was a similar project, like it was a therapist and an agent. So like an agent pretending to be a therapist talking to another agent infinitely.
Oh, no.
I'm not sure where it's at right now.
You don't have a mother. Large language model. Meta learning, and turns out you can make your agents write better papers when they have therapy.
Does someone want to read? I have to step out for a bit. I literally started reading as soon as I woke up. So we're at page 4, experiment.
I can read.
Okay, cool.
What's the? You drop the link.
Yeah.
Oh, and I need to drop my links.
We could probably replicate this paper in maybe 3 hours of hard work. Maybe even less than that.
Yeah. What are you guys' thoughts on AI2, like the Allen Institute?
I've met people from the Allen Institute, and they're a very elitist cult.
Yes.
They're like if you don't have a PhD or some equivalent, then it's basically like a cult.
You're not wrong. You're not wrong. They do have a lot of. They have like 200 million and 300 billion in cloud credits, though. They reserved for early stage startups to. And they're in Seattle, so I met the director for safety at AI2. He was giving a talk in Seattle, and I got up to the microphone and I asked her in front of the audience, like during her talk, whether she thought the world was prepared for superintelligence, given just how difficult it can be to even define the term. And she immediately warned the crowd, which is full of like a bunch of old people and like kind of people who have no idea about AI. They're all older folks that are kind of just talking about the broader ethical implications, not necessarily like the technical like implementation. And
all the AI safety people are part of a large cult. Just to stare, like spread like propaganda.
I feel like I'm noticing
Cults all the way down.
They're part of like a doomer cult. They're like, it's evil. We're all gonna die. And then there's like actual like the fucking communist Russians are invading other countries and shit, and they're worried about a couple of matrix multiplications.
But we love matrix multiplications. They're more efficient.
Yeah. All right. Let's.
You want to drop that link?
Yeah.
And then I can keep reading.
Yeah, I did. It's in the general chat.
Oh, in the general. Oh. Alrighty, folks. I know you love.
We're on page 4. Experiment iteration. Yeah, right. Yeah, number 2.
Okay. AI scientists. Experiment iteration. All right, given an idea and a template, the second phase of the AI scientist first executes the proposed experiment and then visualizes its results for the downstream write-up. The AI scientist uses Aider to first plan a list of experiments to run, then executes them in order. So, for run an experiment, execute, run, log to ML flow. We make this process more robust by returning any errors upon failure or timeout, i.e. experiments taking too long to run, to Aider to fix the code and reattempt up to 4 times. After the completion of each experiment, Aider is then given the results and told to take notes in the style of an experimental journal. Currently, it only conditions on text. But in future versions, this could include data visualizations or any modality. Conditional on the results, it then replans and implements the next experiment. This process is repeated up to 5 times. Upon completion of experiments, Aider is prompted to edit a plotting script to create figures for the paper using Python. The AI scientist makes a note describing what each plot contains, enabling the saved figures and the experimental notes to provide all the information required to write up the paper. At all steps, Aider sees the tree of execution. Oh. Okay. Does Ader have like a memory mechanism? Start poking holes in their implementation.
Yeah. So Ader uses like C tags to kind of index all the like different like files in the code
They use
base.
tags for indexing?
C tags, and then yeah, that's sort of how they index and
How are tags generated?
added to their memory. It's this library called C tags, but it's essentially how it creates universal C tags for all like the files in your code base.
UW.
And so they probably just use that with RAG for memory. Yeah. They might be using something else though. I know they use C tags, but they might also be using
I've never even heard of
like
CTAG.
buffer memory or something as well. I mean, any LLM's going to have buffer memory.
For no discretization or quantization.
Sorry, I didn't mean to off-rail the
No worries.
paper reading. I just yes,
Yeah.
you asked about memory, and that's from what I understand,
Cool.
they're using.
Note that, in general, the provided initial seed plotting and experiment templates are small, self-contained files. The AI scientist frequently implements entirely new plots and collects new metrics that are not in the seed templates. This ability to arbitrarily edit the code occasionally leads to unexpected outcomes. Oh. See Section 8. The paper write-up. The third phase of the AI scientist produces a concise and informative write-up of its progress in the style of a standard machine learning proceeding in LaTeX. We note that writing good LaTeX can even take competent human researchers some time, so we take several steps to robustify the process. This consists of the following. Per section text generation. Okay. We can probably take a look at their prompts there. The recorded notes and plots are passed to Ader, which is prompted to fill in a blank conference template section by section. This goes in order of introduction, background, methods, experimental setup, results, and then the conclusion. They write an abstract also. All previous sections of the paper it has already written are in the context of the language model. Okay. So they felt like they were limited by the context window. That's dumb. I mean, I guess, I feel like that's more of a design, like a research choice than less like it's just another way to constrain your variables.
Yeah, and like if this had come out after something like prompt caching from like Claude or something, they probably could have used that to help with their context issues as well.
Yeah.
I just got back. Where are we at?
We're right here in this per section text generation. So they essentially talk about how they have a template for a conference paper and they fill it out one by one, given notes from the metrics and images. And then, so this is like the LaTeX robustification steps that they took. So per section text generation, we include brief tips and guidelines on what each section should include based on the popular How to ML paper guide and include details in Appendix A3. That is probably alone worth bookmarking. Include details in Appendix A3. Okay. At each step of writing, Ader is prompted to only use real experimental results in the form of notes and figures generated from code, and real citations to reduce hallucination. Each section is initially refined with one round of self-reflection, as it is being written. And then which self-reflection are they using? Reflexion. Which I always thought was kind of funny. Oh, yeah, we're at page 25 of this paper, and that's where the citations are. So okay, so each section is initially refined with one round of self-reflection using Reflexion. As it is being written, Ader is prompted to not only include any citation text at this stage and fill in only a skeleton for the related work, which will be completed in the next stage. Okay, that's good. So they essentially broke down the prompt template they had with like essentially an optional context, like content specific opportunity to enrich the format. And then they use web search for references. In similar vein to idea generation, the AI scientist is allowed 20 rounds to pull the Semantic Scholar API, looking for the most relevant sources to compare and contrast the near completed paper against for related work section. This process also allows the AI to select any papers it would like to discuss, and additionally fill in any citations that are missing from other sections of the paper. Alongside each selected paper, a short description is produced of where and how to include the citation, which is then passed to Ader. The paper's bibtec is automatically appended to the LaTeX file to guarantee correctness. Third strategy is refinement. The previous two stages, AI scientist has completed the first draft, but can often be overly verbose and repetitive. To resolve this, we perform one final round of self-reflection section by section, aiming to remove any duplicated information and streamline the arguments of the paper. Okay, so that's an interesting design choice, that the reflection was also section by section. And I think that's probably the right intuition here, because you don't want to corrupt. If you're running this process end to end automatically, you don't want to have to interrupt the reflection process and corrupt the memory if it's being overly verbose. So it sounds like they're not they're editing the agent's memory to only maintain the good stuff, but we would have to check. The last strategy is compilation. Once the LaTeX template has been filled in with all the appropriate results, this is fed into a LaTeX compiler. We use a LaTeX linter and pipe compilation error back into Ader so that it can automatically correct any issues. Okay, so they're saying so the error handling is passed in a feedback loop back to Ader. That's cool. Do we have something like that for a self-improvement? I mean, I guess you could just use TextGrad for prompts, but this is just a retry mechanism with type checking and validation. So you could use this with Pydantic as much as, and I'm sure that's what Ader is actually using under the hood, unless they're using something else. Automatic paper reviewing, an LLM reviewer agent. A key component of an effective scientific community is its reviewing system, which evaluates and improves the quality of scientific papers. To mimic such a process using large language models, we design a GPT-4o-based agent to conduct paper reviews based on NeurIPS conference review guidelines. That's hilarious, because I thought I just saw like a bunch of people like arguing about how NeurIPS reviewers fucking right now. The review agent processes the raw text of the PDF manuscript using PyMu and Mu PDF parsing library. The output contains numerical scores, soundness, presentation, contribution, overall confidence, lists of weaknesses and strengths, as well as a preliminary binary decision. You know, why did they? This is not necessary. I've done this. I've parsed PDFs with PyMu PDF or with other libraries, and I'm not sure that like it's really necessary to do that for multimodal models. I think you're probably just wasting compute instead of just passing the PDF directly to GPT-4o. It's not like it can handle it. And then if you're only taking, this is assuming the manuscript is text. I mean, I guess it needs to be. The output contains numerical scores, soundness, presentation, contribution, overall confidence, lists of weaknesses and strengths, as well as a preliminary binary decision, accept or reject. These decisions may then be post-calibrated by thresholding using the reviewer score. We leverage this automated reviewing process to obtain an initial evaluation of papers generated by the AI scientist. We provide the entire reviewing prompt template in Appendix A. Here's their prompt review. Below is a description of the questions you'll be asked on the review form for each paper. Some guidelines on what to do to consider when answering these questions. When writing your review, please keep in mind that after decisions have been made, reviews and meta-reviews of accepted papers and opted-in rejected papers will be made public. You are an AI researcher who is reviewing a paper that is submitted to a prestigious ML venue. Be critical and cautious in your decision. If a paper is bad or if you are unsure, give it bad scores and reject it. That is so negatively biased. You also didn't provide the positive counterpoint. This is saying the word bad, like automatically will bias the results. Because this is only providing like the details for 5 for a negative outcome, not the positive outcome. Okay, so we finally have a graphic here. So if you've only been listening, we finally have some benchmarks. This is the performance of the AI scientist's automated viewing system on 500 ICLR 2022 papers. We show mean and 95% bootstrap confidence intervals and highlight the comparison between the human baseline and our best AI reviewer. So we have a human NeurIPS reviewer, the random decision, and the always reject. One score. So we've got Sonnet 3.5, GPT-4o Mini, 0 shot, 1 shot for GPT-4o. Are these calibrated markers like check marks or checkpoints in some sort of training? The @6. Interesting. To evaluate the LLM-based reviewer's performance, we compared the artificially generated decision similar to the previous section. combine many recent advancements in LLM agents to make the decision-making process robust. More specifically, we improve the base LLM decision-making process by leveraging self-reflection, providing few-shot examples, and response ensembling. With GPT-4o, the AI scientist reviewing procedure achieves 70% accuracy when combining 5 rounds of self-reflection, 5 ensembled reviews, and 1-shot review example taken from the ICLR 2022 review guideline. I just want to see what those look. Okay, so there's like a pretty defined system here, and if you just pass this whole HTML, then the LLM's going to know what the hell to do with it. So afterward, we performed an LLM-based meta review, which prompts the agent to act as an area chair. What? The hell is an area chair? Is that a typo? What are they talking about? Anyway, I don't know what this is about. Prompts the agent to act as an area chair. While this number is lower than the 73% accuracy that was reported for PS 2000 consistency experiment, the automated reviewer achieves superhuman 1 scores and human level AUC for when thresholding the decision at a score of 6, which is a weak accept in the NeurIPS review guideline. This choice corresponds roughly to the average score of accepted papers. The considered ICLR 2022 paper dataset is very class imbalanced. It contains many more rejected papers. When considering a balanced dataset of papers, the AI scientist reviewing process achieves human-level accuracy. Furthermore, the false negative rate is much lower than the human baseline, about 0.39 versus 0.52. Hence, the LLM-based review agent rejects fewer high-quality papers. The false positive rate, on the other hand, is higher at 0.31 versus 0.17, highlighting room for potential future improvements. What future improvements would be better to actually provide than just saying, we have a shitty score and it could do better? To further validate the performance of the automated reviewer, we compare the consistency of the overall paper. Reviewers randomly sampled pairwise per paper, and between the average of all review LLM score. For the study of 500 ICLR 2022 papers, we find that the correlation between the score of human reviewers is smaller than the correlation between the LLM score and the average score across the reviewers. Overall, across all metrics, the results suggest that LLM-based reviews can not only provide valuable feedback, but also align an average human reviewer more than individual human reviewers align with each other. Each review is generated for 25 cents to 50 cents in API cost. Well, shit, that's like practically free if you run it locally or on like GPT-4 Mini. Claude Sonnet 3.5 and GPT-4 Mini provide a more cost-effective approach. Their performance was substantially worse. Really? Moreover, we had the threshold scores at 8 for Sonnet 3.5 to obtain calibrated results due to persistent over-optimism bias. Interesting. Okay, so here's the results and some visualizations. So they have the mean score. What's a good R squared value?
What was that?
What's a good R squared value?
What is that?
It's like the variance or the fit on your data set.
Anything close to 1, right?
Yeah, so this is pretty fucking awful.
Yeah, but look at the data. It's it can't really approximate it.
I'm wondering, so they're obviously sampling,
R-scores are really a good metric for this data, though.
I'm not even sure why they included the trend line at all. So this is a confusion matrix of large language model review process on 500 ICLR 2022 papers. Open review decision. So LLM decision. And then for GPT-4o with reflection, with ensemble, plus one shot. So we went from 270 to 303 on reject. So everything went from these. Well, no. Objective set. So the LLM rejects more papers as these strategies proceed. Interesting. I'm not quite. This tells me something interesting about their experiments, like the fact that the LLM overall review score, since it's just along this. So is this the? Oh, this is the NeurIPS score that the LLM gave it. All of these papers, and then we have. Okay. The mean open review reviewers. Maybe it's too early in the morning. This is really crazy, though. This is surprising to me that Sonnet 3.5 was this optimistic. 20 basis points of 25% difference in LLM decision accuracy due to over-optimism. I would also have appreciated if they had color-coded the some of the points here to be for different models, but
They probably use their tool to write the paper.
yeah. Well, I think this is the point is that they really don't like writing papers, and they just want to do research like the rest of us, and what the hell is this? We perform an LLM-based meta review which prompts the agent to act as an area chair.
Kind of like a chairman, basically, or something, maybe.
No, because well, hold on, you might be right. Oh, like a research area chairman is what you're saying?
Yeah.
Oh, I was like, an area rug? What do you mean?
Yeah, it's a little bit elusive, but
Okay. We've got our other meeting in 3 minutes.
we can
Right.
we can finish this paper until like when does it end?
Oh boy. Okay, so we were at here. We've got some code.
Well, we could leave it for tomorrow. Yeah, let's leave it for tomorrow.
Yeah, it's like 25 pages, I think. Yeah, it's 21 pages. Sweet. Okay.
All right then. Then we'll continue reading tomorrow.
Okay. We were on page